Tivoli Storage Manager version 5 to version 6 migration. Upgrading on Red Hat Linux. This is a recording from an earlier webcast that covered the TSM v5 to v6 migration topic in detail. Our speaker is Dave Cannon of the IBM Advanced Technical Skills Organization. If you'd like to see a replay of the entire webcast, look for the link in the comments section of this video. And now, over to Dave Cannon.
All right, so this is going to be, I guess, part 2 of this session. And I'm going to be demoing an upgrade of a Red Hat Linux version 5 to version 6. And these are the topics. Now, what I'm going to do here is I'm going to cover very briefly the method that I'm using to do this upgrade. I'm going to go through some of the configuration specifics so that you can understand the system that I've got here, how it was set up, and some of the specifics as far as RAM and number of cores and so forth. And then for each of the 5 steps that you would use for this particular method, I've got a small video that I'm going to go through, with the exception of the last step. The last step is really some slides that I put in. These are pretty much straight out of the upgrade guide on things that you need to do when you are done with your upgrade, some things that you need to check, some various steps to go through. So let's start off here. First, I'm going to very briefly just cover what this method is. We covered this in the last session in a lot of detail. There's basically 5 steps to this. When I presented this last week, I presented the steps in order, in numerical order here. Now, what I wanted to point out here was that this is the list of steps in the order that they are presented in the book. However, for the purposes of this type of upgrade, you don't necessarily have to do these steps in this order. And the reason for that is that you can be working on your version 6 system, getting that system ready at the same time that you're doing some of the preparatory work that Tom talked about in the first part of this session. So you can be working on these together, and you don't necessarily have to do these in numerical order. And in fact, that's what was done here. What I did on this part of the demo was we were working on the version 6.3.4 system at the same time that we were doing some of the preparatory work on the version 5 system. So the order of steps that we took on this part, on this demo, was we first installed 6.3.4 on the new system. We then went to that 6.3.4 system and we did the DSM serve load format step. And that's the step that does some of the DB2 setup work. It creates a very small empty database, and it does an initial backup of that database. And at that point, the 6.3.4 system is ready to go. It's sitting there waiting for the data that you are going to extract from the version 5.5 system, and then you're going to go over to the 6.3.4 system and do an insert. So that system is sitting there. You then go back over to your version 5.5 system. You do those steps of the prepare DB, the extract DB, and then the last step is when you take the files that have been created as part of the extract. You're going to take those files over to the version 6.3.4 system, and you're going to do the insert. So a couple of points here that I'll make on this demo. First of all, we decided that we were going to use 6.3.4 as our starting point for our version 6 system. Now, what I would recommend at this point, as of today, the recommended levels that you should be going to are 6.3.4.200. So if you're starting off today and you're going to do this migration for the first time from your version 5 system, I would start with 6.3.4.200. On the version 5 system, I would try and get to version 5.5.7 if you can do that. That will save you a couple of steps, and if for whatever reason you have to back it off, you're already at a high level of version 5.5. Another point here is that Tom went through in a lot of detail on some of the preparatory steps that needed to be done on the version 5.5 system. They are the same that you would do for a Red Hat Linux type of setup. So I'm not going to go into the USS conversion issues and all that stuff. Before we did this actual demo, we did all those preparatory steps. We did that first database backup on the version 5.5 system just to make sure that we had something to fall back on if we needed to. So at the point where I start this set of demonstrations, the systems are ready to go. All the prep work has been done. So let me give you some of the specifics here on what these systems look like. Now, really what we've got here on this setup is we've got two VM guests. One of the guests is running version 5.5.7 of TSM. It's got Red Hat version 5.164-bit. We've got 32 gig of RAM, 4 CPU cores. We used a relatively small database for this. It's a 2 gigabyte database that we loaded with some data. It's about 25% full. And keep in mind, this demo, what we did was we are doing a version 5 to a version 6 system. We are using extract to media. And so for the purposes of this one, what we did was we extracted the metadata from the database and we went to disk. Our target server is a version 6.1 64-bit setup. 6.1 is required for version 6, so you need to keep that in mind. And as far as CPU and memory, we have the same setup that we had for our version 5 system. So we've got 32 gig and 4 CPUs. And for this one, we did 6.3.4.0. I would recommend that if you were starting this today, again, that you do a 6.3.4.200. So when we did this upgrade, we're doing extract to media, and so you have to keep in mind that when you're done with the extract part of this, you're going to have a bunch of files that reside on your version 5.5 system, and you have to get those over somehow to your new system, your 6.3.4 system. You can do that in a couple of ways. Now, in this case, what we did was when we were done with the extract, we just FTP'd those files over and made them accessible in the same location names as were available on the version 5.5. Another option that you could do here, we didn't do this for this one, but you could also have an NFS mount. So on both sides, you would have an NFS mount. One system would write the metadata to that location. The 6.3.4 system would then read from that location. Okay, so let's go through the first step here. The first step is going to be the prepare DB. This one is done on the version 5.5 side. This is the source side that you're going to do this on. And one thing I will point out here is the DSM upgrade utility, and that's the utility or set of tools that you're going to download from the FTP site. Those have other capabilities besides just doing an extract DB and a prepare DB. There's actually several other options that you can do with this particular tool. Now, one of the things we discovered yesterday was I did this on Red Hat Linux, and when I ran this DSM upgrade without any parameters on it, I was able to get the syntax for all the ways that this utility could be run. We tried this on Windows, and we tried it on AIX as well, and there seems to be some inconsistencies between these utilities across platforms. When we tried this on Windows and AIX, we just got a syntax error. but at least on Red Hat, you do have some other capabilities here. So, for example, if your TSM server was down and you wanted to extend your log of your server, or you wanted to know how big your database was on that server, in order to do that, you'd have to typically or normally bring up your TSM server in order to just do the query DB. Well, you can run the DSM upgrade utility. You can give it a query DB parameter, and basically all it does is fire up a small version of a TSM server, issue that Q space DB format equals detailed command, and then it shuts down. So at least on Linux, we know that there's some added functionality in this DSM upgrade tool. What we're going to do here, this is the first video, and this is going to be the actual prepare DB step. Now, keep in mind for what I did here, everything is going to be command line based. Tom demonstrated the wizards. I'm going to do command line based here. So what you'll see here is that this looks remarkably like the set of messages that you would see in a TSM server. So, and in fact, that's really what this is. It is the TSM server, but it's just got some reduced functionality. And so, you know, all this did was it started up, it mounted the recovery log volumes, it mounted all of the disk volumes that were on that server, and then it just shut down. Now, the reason that we don't really see any messages here specific to a prepare DB step is because in this case we didn't have any USS conversion issues or anything else that were potential pitfalls that prepare DB needed to warn us about. So this step, as I mentioned last week, it's very fast. It takes about a couple of minutes, 1 or 2 minutes, and then it just shuts down. Okay, so that's step 1. And step 2 is, again, we are on our version 5.5 system, and we're going to do an extract. And the extract is this piece that is going to read the metadata out of the TSM database. It's going to create some volumes that all end in .ost. Those volumes contain the metadata from the database. So we're not reading actual data from storage pool volumes here. We're reading metadata from the database. So one of the steps that you have to do if you're going to use this method is you have to define a device class on your version 5.5 system. That device class is the class that's going to be used to extract the metadata, write it to dev type file, and in this case I defined a device class called extr_class. It had a maximum capacity of the volumes of 2 gigabytes in size, and I specified a location where those files were to be written. So they're all going to be placed in /tsmdata/extract. Now, we had a lot of questions last week about what is this manifest file, what does it look like. So what I did here was when this extract was all completed, I typed out the file, I catted it out, and this is what the file looks like. So you can see the device class name in the file that was used to do the extract, and then you can see the number of streams that were used to extract data out of the database, and then you see the parameter volume names, and you would see one line for every volume that had been created that contained extract data. In this case, we had a very small database. Each file could be up to 2 gig in size, so we only created one volume. And then the last part of this is the actual defined device class that was used. And so when we go over to our TSM version 6 system, this manifest file is also going to be there, and when we start the insert, that device class is going to be defined on our version 6 side, so it knows where to go to get the metadata files, and then it starts reading from those files and doing the insert. So that's what the manifest file looks like. And again, when we finished this part of the demo, when we finished the extract, we had the manifest file and these OST files that were created, and we had to get those over to our version 6 system. So we had to FTP them over to the system. Okay, so that's the extract syntax. Now we're going to actually go in and we're going to show you what the extract part of this looks like. And again, this is very fast. So you can see here, this is the command that I used to do the actual extract. It has the extract DB parameter in it. It has the device class that I want to use to do that extract. I give it the name of the manifest file that I want to create, and then I say use scratch volumes. So you can see this starts up. Again, it looks very much like a normal TSM server startup. It's going to notice that it's going to do an extract. So it opens and creates the first file. There's the .ost file that it created. And then it goes ahead, reads the metadata out of the database, creates those files, and then when it's all done, it's going to issue messages that, you know, it did so many objects, it read so many database pages, it wrote so many bytes, and it's going to give you the throughput estimate for that extract. And as far as what you can expect here, again, this part of the process takes about as long as doing a database backup. So just for estimation purposes, that's what you can figure on. So at this point, we are done with our version 5 system. We've done the prepare, we've done the extract, and now we're ready to go over to our version 6 system and get it running. So next part of this would be the load format. And this is the step that is going to do some preparatory DB2 work. It's going to create our instance. It's going to create a very small database. It's going to do that initial backup. So let's do that one. Here's the command that I executed to do this load format. I'm giving it the name of the database directories. I'm giving it the name of the active log directory and the archive log directory. But notice also I have specified here the active log size. I'm creating an active log that is 8 gig in size. So it's a little bit bigger than what Tom used for his demo. He used the minimum allowed, which was 2 gig. But the reason I want to point this out is that in this step, this load format step, we had some customers that complained that it appeared to be frozen or hung when they were doing this load format step. And there's no cause for alarm here. What's really happening is that it's going to start up here. Let me start it up here. And again, you're going to see typical TSM server messages that are issued. Here's the start of DB2. The database manager successfully started messages. So DB2 has started under the covers. And then you're going to see a long wait at this point. And this is where customers have been questioning whether or not everything was working fine. Well, what's really happening here is you've specified 8 gig of active log files. So each of those files is about 500 meg in size. And what's happening at this point is DB2 is formatting those active log volumes. So this might take longer than you would expect, but everything is working correctly. So at this point, we have completed the formatting of the logs. DB2 is loading stuff into its buffers, and there's the formatting of the database is complete, and then TSM shuts down. Okay, so it's going to take a backup of this database that it's created, and when it's all done, it says backup of offline database has completed successfully. So at this point, you've got your database instance created, you've got your logs formatted, and at this point, you have to make sure that you're ready to do the insert. So let's go back to our presentation here. Now, one thing that I would point out here that I tell customers to do is you've got all these volumes that you extracted to on your version 5 system. When you do the insert, you actually have the ability to do a dry run. So before you create any real data in your database, before you do any of the validation of the data that's in the extracted files, you can do this dry run, and what it will do is it'll verify that your device class is set up correctly, that you've got the volumes created in the right location. It'll actually open and read those volumes to make sure that everything is good. You've got everything in place. And I tell people to take this step because you may not have copied over, for example, all of the files properly. Well, this allows you to do the dry run to make sure that everything is set up correctly before you do the real thing. So let's go back again to our videos here. So we're going to do this insert, and only instead of doing the actual run, we're going to do a preview. So you'll notice up here I've specified DSM serve insert DB. I specify preview equals yes, and I give it the name of the manifest file. So this is that manifest file that I created over on the version 5 system that I've now copied over. So I start up the preview. Again, you see DB2 start up, you see TSM start up. It's going to fire up the buffers, and it's going to go through and it's going to do everything except that last step. So you can see the preview equals yes. So it's going to read through all of the OST volumes, so you can see the one that was created there. It's going to open that up, and then it's going to verify that it was all readable. And then when it's all done, it's going to stop DB2. That's the stopping the database manager message. And then at the end of it, it's going to shut TSM and DB2 down. So you can see here that everything appeared to be okay. It didn't report any missing files. The files were all readable. So at this point, we're ready to go to the next step. And there's really no difference between this step and the previous step, except we're specifying preview equals no. So again, we're going to fire this up. You can see that in this case, the file is opened. It's going to start building the indexes and doing the table integrity checks. When it's done reading all of those volumes, it's going to close everything out. And then at this point, this is the step that does what's called run stats. Whenever there are massive updates to a database, DB2 always requires that you run a run stats command to update how many objects are in the table, how many records are in the table, and so forth. And it uses that statistical information for optimal access to the data in the database. So this is always run at the last phase of the backup, and when it's done running run stats against all of the tables that have been created, then it's going to give some final statistics as far as how many tables were created, how fast it was, how many objects were created, and so forth. And then at that point, it shuts down, and your database is ready to go except for one thing. And this is a key difference between what Tom did with the wizards and what I do with the command line. And this is something to be keep in mind. These are the steps that need to be done after the upgrade is finished. Now, one key difference is that when you run the wizards, the configuration of the database backup is done for you. When you do this via the command line, when you're running all of these command line utilities, that step is not done. So you do these steps first. You're going to ensure that the storage devices are all accessible on the new server. You should compare the device names. You might have flipped over to a new server that had different tape drive names, so you've got to ensure that those are all correct. You're going to have to go out. You're going to have to upgrade all of your clients to point to that new TCP server address, and you're going to have to do the verification. Tom went through this on his part. Do the verification that you can connect with the admin client. And you also have to register your licenses. Okay, but this is the key step that is not done when you use the command line utilities versus the wizards. You're going to have to make sure that your TSM database backup is configured. So you're going to establish a device class that's used for the backup. You're going to do a set DB recovery command, pointing it to that device class. And then when you're done with those two steps, you should take a backup of the database with a type equals full, and you should also back up the volume history file.
Thanks, Dave. If you'd like to see a replay of the entire webcast, including migration demos for AIX and Windows, here's the link for the entire replay. Thank you.